दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. After the discovery of the two fundamental particles, the electron and proton, attempts were made by different scientists to explain a model of atom. What we mean by the word model of atom? Atom is the smallest particle of an element, may or may not has pre-existence, cannot be further subdivided, was proposed by Dalton. Now the same atom was found to have two subatomic particles, electron and proton. I am not telling about neutron now because we will be discussing the model of atom before the discovery of neutron. So I am not taking neutron into account now to explain the model. While discussing the model of the atom, I am using the two words electron and proton only. So a model, how the atom look like, varies to configure the electron and proton inside the atom. The electron is the negatively charged particle, has negligible mass. Proton is a positively charged particle, has mass almost equal to that of hydrogen atom. These are two discoveries made by 1905. So in between, the radioactivity was discovered by Henry Becquerel, and it was found that the atom of certain elements like radium, uranium, thorium, neptunium, they are undergoing spontaneous disintegration to produce energetic radiations which were named as alpha rays, beta rays and gamma rays. This is the discovery made towards 1903. So the science was developing very fast at that time. So the first attempt was made by Rutherford to explain a model of atom, and the model of atom is called Rutherford nuclear model of atom. Before that, a model of atom was proposed by Thomson, where it is nothing. He proposed that the electrons and protons, they are spread over the atom, but he could not configure the electron and proton inside the atom. How are they? And the first attempt was made by Rutherford in near about 1908 to 1911. In between these 3 years, a model of atom was proposed by Rutherford, and that model is called Rutherford nuclear model of atom we are going to study now. Now how this he carried out an experiment. The experiment is called as scattering. From the experiment, scattering of alpha particles, by a gold foil. This is the experiment he made, and from this then what is this alpha particle? Now alpha particle is alpha particle has 2 units of positive charge and 4 units of atomic mass. It is helium atomic mass 4 and charge 2. It has 2 units of positive charge. That means when helium atom loses 2 of its electrons, it forms a positively charged ion, and that positively charged ion is as good as the alpha particle. So he carried out this alpha particle from a radioactive element, and from the radioactive element he allowed these alpha particles to strike a gold foil, and that experiment is called as scattering of alpha particles by a gold foil. From there he proposed a model of atom called nuclear model of atom, which is the first step taken, very bold step taken by the scientist Rutherford to propose a model for atom. What was this scattering of what was the experiment, this scattering of alpha particle by gold foil? To explain this, what he did, he took a gold foil of 400 angstrom unit thickness. So its thickness is 400 angstrom unit. 1 angstrom unit is 10 to the power minus 8 centimeter. That is almost very, very thin 0.0004 centimeter. So you say that 400 angstrom unit. He take a gold foil and he kept in a box, and the entire box is covered by zinc sulfide screens from back side, front side, every side. So think about a room. In the middle of a room, you think you have kept the gold foil. At one end, he is allowing the alpha particle to enter, and the walls are there. This is a wall. He covered them zinc sulfide, zinc sulfide, zinc sulfide, zinc sulfide, backside zinc sulfide. Why? Now, because any charged particle, when hits upon a zinc sulfide, it produces a scintillation, a bluish green light, and that is called fluorescence. So that these alpha particles can be seen. Where are they going? That can be seen. So he took a gold foil, covered all its around by metal gold foil, and allowed the alpha particles to strike upon a gold foil. When fast moving alpha particles were bombarded against a thin metallic gold foil of 400 angstrom unit thickness, this is a gold foil of 400 angstrom unit thickness, the following observations were made by Rutherford. So what he did, the first observation he got, when fast moving alpha particles were bombarded, these are from a radioactive source, so he allowed the alpha particles to strike upon a gold foil of 400 angstrom unit thickness. So this, like this. So he made 3 observations, 3 definite observations he made. He found what? Most of the first observation, most of the alpha particles penetrated the gold foil. Just they came and went back. See, this gold foil is here. They are hitting the alpha particle on the gold foil. This side, the end of the box. So here they produced scintillation. They went straight and produced scintillation. So most of the alpha particles penetrated the gold foil. Most of the alpha particles, they penetrated the gold foil like this. The first observation. Second observation made, some of the alpha particles got deflected in smaller and larger angles. So some alpha particles, they come, they hit upon the gold foil and they got deflected like this. So this is the angle of deflection. And another alpha particle came like this and hit upon the gold foil and it got deflected like this. So this is the angle of deflection. It should have gone like this, but this angle here is deflected. So another alpha particle, when it comes and hits upon the surface, it got deflected in this way. So this came in this way, and this is the angle of deflection, a large deflection. And some of the alpha particles, they come like this and they were deflected in smaller angles and smaller and larger angles like this. They got deflected in smaller and larger angles like this. They were deflected. So 1 in 10,000 of alpha particle got back deflected. It went like this, strike the gold foil, then again it retraced its path. Again it came back to the same path. So on this side the alpha particle entered, this is the gold foil, it struck the gold foil, then again came back on this wall, it produced the fluorescence. So retraced their path. When fast moving alpha particles were bombarded against a thin metallic gold foil of 400 angstrom unit, the following observations were made by Rutherford. What is one first observation? Most of the alpha particles penetrated the gold foil. Second, some of alpha particles the alpha particles got deflected in smaller and larger angles, in smaller and larger angles. And third observation, he made very few of alpha particles, that is as good as 1 in 10,000. 1 in 10,000 of particles got back deflected and retraced their path. Means the path in which they went, again they came in the same path. Means 100, this is the path, means they should have gone like this. So what is the angle? The angle of deflection is 180 degree maximum. So there are three observations he made. When fast moving alpha particles were bombarded against a thin metallic gold foil, then 400 angstrom unit, then the following observations were made by Rutherford. Most of the alpha particles penetrated the gold foil. Second, some of the alpha particles got deflected in smaller and larger angles, and very few of the alpha particles got back deflected or retraced their path. Then why he took the gold foil? The gold foil, he wanted to prepare a metallic foil of very small things, and this gold is highly malleable and ductile. It has a large gold atom, atomic number is 79, so it has a large atomic mass. So there are many protons and electrons must be present inside the gold atom. So protons are there, means 79 protons will be there inside the gold atom. And so one alpha particle, what is the charge? The charge of a particle is 4 units of atomic mass and 2 units of positive charge. So he want to find out. So by this experiment he could conclude he concluded his observations. So what observations he made for this experiments? The alpha particles, made the conclusion, alpha particles have 2 units of positive charge, 2 units of positive charge and 4 units of atomic mass are massive charged particles. Massive charged particles, and they are moving also with very high velocity, almost equal to the velocity of light. And then he may want to make the conclusion. So most of the alpha particles are penetrated the gold foil. What is a gold foil? Gold metal. So gold atoms are there. So layers of gold atoms are there. So when it is, that means when it is heating, then how is the gold foil? 400 angstrom unit. Means it is as good as one atomic size is 10 to the power minus 8 angstrom unit. So it is 400 times its size is bigger than the size of an atom. So that means atoms are there very close to each other. So this they are penetrating. So he concluded now, since most of the alpha particles are penetrating the gold foil, there must be large hollow space inside the atom. Since most of the alpha particles are penetrating, because atom consists of protons, so in gold atom there are 79 protons, still then these alpha particles are penetrating, no deflection. Means that the 79 protons present in an atom of the gold atom, they are not having any effect upon the alpha particle. Hence the atom must be consisting of a large hollow space. So it was concluded, it was concluded by Rutherford that, what is that? Since, first number one, since most of the alpha particles are penetrating the gold foil, there must be a large hollow space, means vacant space, a hollow space inside the atom. Inside the atom there must be a large hollow space inside the atom. So he thought that if this is an atom, if we think this is an atom and most of the alpha particles are penetrating, so there must be large hollow space inside the atom. Hence these alpha particles are not undergoing any reflection, and they are going this and they are coming out of the atom. They are going to the atom, they are heating up the atom, and they are penetrating the atom, and they go next side. So if the atom is there must be a large hollow space inside the atom. Second observation, alpha particle is positively charged and has 2 units of positive charge and 4 units of atomic mass undergoing deflection. Hence there must be a positively charged massive body present inside the atom of the element to cause this deflection because of the mutual repulsion. We know like charges repel, and positive charge, this alpha particle is a positively charged, it is undergoing deflection, means there is a repulsion going on. So there must be coming across these positive charges present inside the atom. Since alpha particles are positively charged and undergoing deflection, so there must be a positively charged center, inside the atom to cause these mutual repulsion. He says, what he says here? He says there must be a positively charged massive body present in the atom. Alpha particle is positively charged, so those which come nearer to this positive charge, so positive charge will repel the positive charge, so it is undergoing repulsion. And another particle comes like, so it is undergoing repulsion. Another particle comes like this, it is undergoing repulsion. The particle goes like this, it is undergoing repulsion. So those come to very close to this, they undergo repulsion. So the angle of repulsion depends upon how close the alpha particle is coming to nearer to this positively charged massive body present inside the atom. Since alpha particles are positively charged and undergoing deflection, so there must be a positively charged massive body present inside the atom, causing deflections because of the mutual repulsion. Then comes the third observation. He concluded third observation. So to conclude the third observation, he proposed, what has happened here? 1 in 10,000 of alpha particles. So 1 particle in 10,000. So when this alpha particle is going like this, comes very close proximity of this positively charged body, the repulsion is maximum. Repulsion is maximum. Because of maximum repulsion, the angle of deflection that comes to 180, so it is retracing its path. So to conclude the third observation, he says those alpha particles which approach to the close proximity of this positively charged massive body present inside the atom, the angle of the mutual repulsion is maximum, which causes the back deflection, or retracing of the path of alpha particle. So those alpha particles, they approach the close proximity of this positively charged massive body present inside the atom. The mutual repulsion is maximum, hence the angle of deflection is highest. The angle of deflection becomes 180 degree, and hence it becoming retracing its path. So then what two conclusions is made about the atom now? Atom has a positively charged massive body present at its center, and there is a large hollow space inside the atom. So the atom consists of a positively charged massive body and a large hollow space inside the atom. So from these three observations and conclusions, now he made a conclusion, final conclusion about the atom. He says, hence, what is this? There is a positively, two things. There is a large hollow space inside the atom and a small positively charged body present inside the atom. So then what the positively charged body must be consisting of? It must be consisting of the protons. So he says, so there is a positively charged massive body present inside the atom, and there is a large hollow space inside the atom. This is the way he says. So here there is the hollow space, and this is the positively charged massive body, and he named that nucleus. He named it nucleus. He called this positively charged massive body as named, not that discovered nucleus. No, under no circumstances we should use a word discover the nucleus. He named that positively charged massive body present inside the atom as a nucleus. Why? Nucleus is a word he borrowed from the English dictionary to explain by one word. He explained what is nucleus? Origin. All these three observations are originating because of this positively charged massive body. It is the origin of all these observations, because this positively charged massive body is very, very small, present at the center of the atom, and there is a hollow space. Because of hollow space there is a penetration, and because of positively charged massive body there is deflection, and the positively charged massive body is very, very small space. All these protons are present. So this nucleus consists of what? All the protons are present inside the atom now. He concluded. So this is the way he configured that. So now what conclusion made? The atom consists of a positively charged massive body placed at the center of the atom, placed at the center of the atom, consisting of the protons, and there is a large hollow space all its around. There is a large hollow space and around, and this positively charged massive body present inside the atom was named as nucleus. And then where are the electrons? So now the electrons are moving around the nucleus in circular orbits, in a circular orbit, circular path. So this is a path, circular path, and in this circular path these electrons are moving. These electrons are moving. This orbit he called as a path. This is called as the orbit, circular path, and the electrons are moving around the nucleus, around this nucleus. So taking the nucleus, he proposed the model of atom, and he called as the nuclear model of atom. He took the nucleus and proposed the model. Then how are the electrons are moving? The electrons are what? These electrons are what? They are negatively charged, and they are moving around the nucleus. Then what he says now? How the electrons are not falling into the nucleus? Why they are not falling into the nucleus? Why the electrons are not going away from the atom? To explain that he proposed. So this is a nucleus placed at the center of the atom, and the electrons are moving around the nucleus in a circular orbit. And now since then there is a negative charge, there is a positive charge, so there is a attraction between them. This is called force of electrostatic attraction between the nucleus and the electron. There is attraction. This attraction is called nuclear force of attraction. Nuclear force of attraction. Then and it is moving in a circular orbit. So when circular orbit, so this electron will be trying to go out of the atom also. Suppose you take a stone and tie it by a thread, then rotate the thread, that rotate the stone on your finger. You will feel a force on your finger. Why? Now that stone when moving, it will be trying to go out. If you cut the thread, the stone will go and fall at a distance. So the electron is moving with a very high velocity around the nucleus. So it is always having a outward centrifugal force. This is it has a outward centrifugal force. This new electron have outward centrifugal force. This outward force, centrifugal force of the electron, is balanced by what? By the force of electrostatic attraction between nucleus and electron. So this he proposed. So he says the nucleus consists of the protons, is placed at the center of the atom. Entire mass of the atom is concentrated at the nucleus. Mass of the atom is concentrated at the center, at the nucleus. The electrons are moving in circular orbit. The electrons are moving in circular orbit around the nucleus. How? Such that, how they are moving? Such that this outward centrifugal force of the electron due to circular motion is balanced by the force of attraction, force of electrostatic attraction existing between the nucleus and the electron. Hence the electron keeps on moving around the nucleus without falling into it. So by a very wonderful way he configured the proton and electron inside the atom from this experiment called as scattering of alpha particles by a thin gold foil, and proposed the model of atom taking the nucleus. Hence he named the model of atom as a nuclear model of atom. So this model of atom proposed by Rutherford is comparable with the solar system. It is comparable with what? It is comparable with what? The solar system. The sun is the nucleus. The sun is compared to the nucleus. The nucleus is just like a sun. The sun is there and all the planets are moving around the sun, here also the electrons are moving around the nucleus. Hence, inside the atom, just like a solar system, there is a nucleus and there the electrons are moving around the nucleus. So he called these electrons as planetary electrons. He called these electrons as a planetary electrons. And this is comparable to the solar system. This is comparable with the solar system, and these electrons were called as a planetary electrons. And this is the model of atom, and for this model of atom, Rutherford was awarded the Nobel Prize, because nobody knew how the atom is. Rutherford has also not seen the atom. He thought how the atom must be. Where are these electrons and protons? How they are configured inside the atom? He proposed the nucleus consists of the protons. The entire mass of the atom is concentrated at the nucleus, and the nucleus is positively charged. The charge of the nuclear charge is equal to the number of protons. The number of protons are equal to the nuclear charge of the atom. And the electrons are what? The electrons are moving around the nucleus. They are moving in electron moving around the nucleus in circular orbit. In the circular orbit. How they are moving? Due to they are making a circular motion. Because in circular motion there is a centrifugal force and centrifugal force. The centrifugal force is what? The force with which the particle wants to go away from the path of moving. That is called centrifugal force. So the electron will be having a tendency to go out. So the electron is not going out of the atom. It's not going out of the atom. Why it is not going out of the atom? Now, because the nucleus is attracting here, the nucleus is attracting here, the nucleus is attracting everywhere, the nucleus is attracting the electron. And this attraction is called as a force of electrostatic attraction. Existing between the nucleus and the electron is balanced by the outward centrifugal force. Hence the electron keeps on moving around the nucleus without falling into the atom, and this nuclear charge is equal to the number of protons present in the atom. Nuclear charge is equal to the number of number of protons present in atoms, and the number of electrons are equal to number of protons, because the atom is electrically neutral. And this is called as the Rutherford nuclear model of atom, or the planet. This is comparable with the solar system. This is comparable with the solar system. The nucleus is compared to the sun, and the electrons with the planets. Now this is the way the model of atom, Rutherford model of atom, was accepted as a very scientific model and called as the Rutherford nuclear model of atom. Then after this, then came objections raised upon this Rutherford model of atom. After some years, there was an objection raised on the model of atom, basing on what? Basing on the theory of radiation. So that is called, there is a limitation. I am not calling this is a defect. Many books they are writing defects of Rutherford model of atom. Actually there is no defect. We can say that limitations of Rutherford atom. There was an objection. There is a limitation of Rutherford model of atom. It could not account for certain objections. Model of Rutherford model of atom. What they say? Suppose what are the objection? Now the electron is a charged particle. Charged particle is moving around the nucleus, which is positively charged. So according to the classical theory of electrodynamics, any charged particle while moving around another charged particle will radiate energy. So this is the theory of classical electrodynamics. Any charged particle while moving around another charged particle radiates energy. For example, we take a fire and keep on the table, keep outside. After some time we find the fire becomes ash. All the heat that was present in the fire is radiated. That means what? The heat energy which was present in the fire is no more there. it has been radiated to atmosphere. So this same thing will happen to the electron. This was the objections made to the Rutherford model. So objection was raised to model of atom. So this is the atom, and the atom is has a nucleus placed at the center. The electron is moving around the nucleus in circular orbit. This is proposed. Now this electron will radiate energy. This electron while moving will radiate energy. Any charged particle while moving around another charged particle would radiate energy. So then the energy of the radiation, the energy of the electron will steadily decrease. From this point to this point, when it comes, its energy will go decrease, then decrease. Then what is there? There is always a force of attraction toward the center. There is a force of attraction toward the nucleus is pulling the electron towards it, and the electron having outward centrifugal force, this. So the energy, what is the energy? The energy is equal to what? Force into displacement. The energy is force of displacement. Now the energy is decreasing. Means what will happen? The force is there, so the displacement will decrease. So this distance present between the nucleus and the electron will be steadily decreasing. So then it will radiate energy. Hence this will no longer move in a circular path. It will move in a spiral path. The time to time the energy will decrease. It will no longer move in a circular path. It will move a spiral path. The radius of the orbit will steadily decrease and at last plunge into the nucleus. The electron is moving around the nucleus. The energy, the outward centrifugal force is equal to the force of electrostatic attraction existing between the nucleus and the electron. The energy of the electron will decrease, means force of attraction, outward force will decrease and inward force will increase. So this nucleus will pull the electron towards it. Hence this radius will go on steadily decreasing. So it will no longer move in a circular path, it will move in a spiral path, and this is and plunge into the nucleus. There is a probability for this. If this model is correct, then this is possible. Since the electron never falls into the nucleus, hence the model of atom has to be, there is somewhere some fallacy, and that has to be revised. That has to be modified. So this objection was raised upon the model of atom, that the electron is a negatively charged particle moving around the nucleus in circular orbits. Its outward centrifugal force is equal to the inward force of electrostatic attraction in the nucleus between the electron. Since the electron is a charged particle moving around another charged particle, it ought to radiate energy, as a result of which the energy of the electron will steadily decrease. Hence it will no longer move in a spiral path, in a circular path, will move in a spiral path. The radius of the orbit will steadily decrease and at last plunge into the nucleus. But the electron never falls into the nucleus. Hence the Rutherford model of atom has to be modified. That means there is something else. There is something else inside the in the Rutherford model of atom that has to be revised. That has to be revised. Means some restrictions, some more restrictions have to, conditions have to be, if can be imposed or given upon the Rutherford model of atom, then this objection can be corrected. So this was the discovery towards 1911, and Rutherford model of atom then needed modification. So in the meantime, towards 1905, Max Planck has already proposed Planck's quantum theory of radiation. This classical theory of electrodynamics, that theory of radiation was almost have been overruled by the Planck's quantum theory. And taking this Planck's quantum theory, model of atom, and theory of electromagnetic radiation was also discovered. So Planck's quantum theory plus how the radiation take place, that was called the theory of electromagnetic radiation. Taking this into account, the theory of electromagnetic radiation and Planck's quantum theory in the year 1913. After 2 years, in 1911, this objection was raised. After 2 years, in 1913, Niels Bohr, a Danish scientist, revised the model of atom, Rutherford model of atom. He modified the Rutherford model of atom, is called as Bohr model of atom. So taking into account the Planck's quantum theory and the theory of electromagnetic radiation, the Rutherford model of atom was revised by Niels Bohr, a Danish scientist, called as Bohr model of atom. So before going to that, what is that Bohr model of atom to study? We have to study what is called Planck's quantum theory, and second is theory of electromagnetic radiation. These two discussions we will make after studying Planck's quantum theory and theory of electromagnetic radiation. We will discuss the Bohr model of atom. So next class I will be talking to you what is Planck's quantum theory and what is theory of electromagnetic radiation, and then we will go to what is called Bohr model of atom in the year 1913, the Bohr model of atom for which the Bohr was awarded the Nobel Prize in the year 1925. Next class we will be discussing Planck's quantum theory and theory of electromagnetic radiation.